Hello students, good evening. I'm your physics teacher Vikal and आज हम लोग शुरू करने जा रहे हैं सेकेंड लॉ ऑफ थर्मोडायनेमिक्स। सेकेंड लॉ ऑफ थर्मोडायनेमिक्स। अंकिता फिर उसको वीडियो को पीछे ले जाके उसको दोबारा से देखो, समझ आ जाएगा। ठीक है, चलो सेकेंड लॉ ऑफ थर्मोडायनेमिक्स। ओके, सो फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स, व्हाट इज फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स? पहले हम लोग समझते हैं फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स क्या कहता है। फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स is what? Is conservation of energy. Is conservation of energy. It is another form of conservation of energy. What is conservation of energy? Energy can convert in one form to another form. Okay, but we cannot create energy, neither we can destroy it. This is the conservation of energy. Okay, so first law of thermodynamics says same thing. As we have seen in heat engine is what is heat engine? Heat engine was like this. Okay, it was source is at high temperature, it was sink was at lower temperature, and it is heat engine. And what will happen in heat engine? What happens? Heat is taken from the higher temperature. You can see in the engine fuel burns. Fuel burn. Okay, when fuel burn, what happens? Heat produces, and that heat is taken by the engine. That is Q in. Okay, now what happens? By using that heat, piston moves up and down, and because of that movement of piston, what happens? Wheel of the vehicle, or like our car or bike, that start to rotate. So what are we getting? We are getting work, output work. Okay, now some heat will be rejected to the surrounding. As we can see from the silencer, you can see that is heat rejected from the silencer of car or for a bike. That is the exhaust. Okay, so from the exhaust, that is the exhaust of the car or bike, from that some heat will be rejected. Okay, so first law says how much is input, how much heat is taken, that can be converted into work also. That can be converted into work also. Okay, first law नहीं कहता है कि सारा कि थोड़ा भी heat will be given to the surrounding also, like heat will be rejected to the surrounding. First law does not say that heat will be rejected to the surrounding also. Okay, first law says you take heat and you convert completely into work. But as we know practically, efficiency of heat engine cannot be equal to 100%. As we know, efficiency of heat engine cannot be equal to 100%. No engine can produce 100% efficiency. Why it can't produce 100% efficiency? I will tell you. As we know, what was the efficiency formula of heat engine? Efficiency formula was work output. It was W, how much work we are getting, divided by input, how much heat we are taking. Okay, so work output, how can we write? Work output we can write as Q in minus Q out divided by Q in. Like that we can write. Okay, and this we can write as, how can we write? This we can write as T1, or we can say TH minus TL divided by TH. Okay, now first law says no need to reject heat. You can convert the whole heat into work. Okay, this is first law. Now we will see. That means Q out is zero. Now first law says you no need to reject heat. Q out will be 0. Okay, first law says, that means if Q out will be 0, you have to put lower temperature also 0 Kelvin. Lower temperature also should be 0 Kelvin. So to achieve 0 Kelvin, temperature is impossible. It's impossible. 0 Kelvin temperature is what? It is minus 273 degrees Celsius. Okay, so it is impossible to achieve that temperature, because at that temperature, what happens? At that temperature, atoms or molecules, there will be no velocity, or there will be no vibration, no motion will be there. Everything will be like, it will be like in super condensed state. Okay, so it is not possible to achieve 0 Kelvin. So that's why Q out we can't take 0. If it was possible that TL can be 0 Kelvin, then we can say no need to reject heat to the sink. How much heat you are taking, that much can be converted into work. If heat is rejected, that's why efficiency is below 100%. If heat is not rejected, then efficiency can be 100%. If Q out is 0, then Q in equal to W out. If both are equal, then we will get 1. 1 means 100% efficiency. But as we know, practically it is impossible, because I told you reason. Reason is 0 Kelvin. To achieve lower temperature equal to 0, that is impossible. That is impossible. Okay, that's why efficiency of engine cannot be 100%. Cannot be 100%. Similarly, as we know, for refrigerator, COP is what? COP is heat extracted divided by W in. Okay, and that was another formula, TL by TH minus TL. So COP in refrigerator, what happens? Refrigerator, this is the refrigerator, TL, this is refrigerator, and this is TH. So as we know, repeat sir, what repeat? COP in refrigerator, COP is QE by Q extracted divided by WN, work input. In previous slide we have seen. You can go to like पीछे जा सकते हो वीडियो में, तब जाके देख सकते हो क्या COP क्या था. ठीक है, so COP is QE by WN, that is equals to TL by TH minus TL. Okay, now as we know, to extract the heat from lower temperature, we have to do some work on refrigerator. Okay, but first law says no need to do work. Simply you take heat from here, we can say Q extracted, and you reject here. Simple. Q out. First law just says conservation of energy. How much you are taking, that much you can reject. Simple. Or how much you are taking, that much you can convert into work. First law does not say that you need work, but second law says. Now here comes second law. Second law restrict it. Okay, if W in equals to 0, put here W in equals to 0. If you will put W in equals to 0, then COP will become infinite. So infinity COP is impossible, because it is not possible without external work. You can't extract heat from lower temperature. Heat always flows from higher temperature to lower temperature. Heat never flows from lower to higher. Here heat is flowing from lower to higher. We are removing heat from lower temperature because we want to maintain lower temperature. Okay, so heat cannot flow automatically from lower temperature to higher temperature. That's why we have to do some external work, and because of help of this external work, heat can be extracted from lower temperature. Okay, so second law, what does second law says? Second law says efficiency of heat engine cannot be 100%. That is correct statement. Cannot be. It cannot be equal to 100%. Okay, and COP of the refrigerator cannot be infinite. Understood? Understood what is the significance of second law of thermodynamics? Second law says, without rejecting heat, you can't get output work. Without rejecting heat from the engine, you can't get output work. You should reject some heat. You should reject some heat to the atmosphere so that you can get output work. This is one statement of second law of thermodynamics. Okay, another statement is what? It is related to refrigerator. In refrigerator, without doing external work on the refrigerator, you can't extract heat from lower temperature, or heat cannot flow from lower temperature to higher temperature. Here you can see heat is flowing from lower temperature to higher temperature. So without external work, heat cannot flow from lower temperature to higher temperature. Understood? I hope all of you understood. What does second law says? Second law puts limitation on 100% efficiency of the engine and infinite COP of the refrigerator, because practically it is not possible. Understood? I hope all of you understood. Chalo. So there are two statements of second law. First is Kelvin-Planck statement. Second is Clausius statement. So what does they say? What did they say? Kelvin-Planck. Kelvin-Planck statement is related to heat engine. Heat engine. Okay. Heat engine. Heat engine. So what is that statement? Simple. No heat engine can convert heat fully into work. That means efficiency cannot be equal to 100%. This is Kelvin-Planck statement. Okay, and Clausius statement is related to refrigerator. In last slide we have seen Clausius statement is related to refrigerator, and it says, what does it say? It says heat cannot flow from lower temperature region to higher temperature region without doing external work on system or refrigerator. Understood? So heat cannot flow from lower temperature region to higher temperature region without doing external work on the system or refrigerator. We need to do some external work on the refrigerator, then heat can flow from lower temperature to higher temperature region. Then refrigerator can work. Or in other words, we can say COP cannot be equals to infinity. ठीक है, यहाँ efficiency 100% नहीं हो सकती, यहाँ COP infinity नहीं हो सकती. Simple. I hope all of you understood two statements of second law of thermodynamics. So I hope all of you understood what is a refrigerator, how it works, what is COP of refrigerator, and second law of thermodynamics also, like what does it say? Second law of thermodynamics puts restriction that we can't convert whole heat into work, or we can't flow heat from lower temperature to higher temperature without any work. Okay. So I hope all of you understood both topics, refrigerator and second law of thermodynamics. So for today, that's it. If you like this video, give thumbs up and subscribe the channel, and please share with your friends. Okay. So for today, that's it. Thank you.